Hello and welcome to this very first tutorial where we will try to come up with solutions for programming assignments, and today's topic is programming assignment 1, which I uploaded some 2 or 3 days back in the group. Yes, so before I jump into coding, let's try to recall what I actually asked for in the programming assignment 1 sheet. So we have features list, we have target list, right? And we wanted to find out the probability of features given target for both of the target classes, right? I hope this did not confuse you that much, as I gave you a hint that how you can actually solve this problem. So this is the actual formula. So now I'll try to explain this and then I'll start coding. So probability of features given A, or probability of features being A given that target class is yes, we have this formula to find this value for any given domain, right? So in the first part we have probability of target being yes given features being A. So how we can actually find it out? First, take a look at the combination features equal to A and target equal to yes, right? So we have to look for number of combinations in our domain, like A being yes. So they are consecutive lists where A is holding this target, B is holding C is holding this target, D is holding this target, and so on and so forth. So we have to specifically look for this combination where feature equal to A and target equal to yes. So the number of this particular combination divided by target being yes, right? Total number of target variables being yes, right? That we have to find out from here. Like here we have 1 2 3 4 5 6 7 8. So we have total 8 yes values in target list. So this is how we can find out probability of this combination. Then we have probability of target being yes, which is very straightforward, 8 by 15, because we have total 15 element in our list, and divided by P of feature being A, probability of feature being A. That's just the same thing that I mentioned right now, that I explained right now, and we have to perform it over this list, right? So we have all these 3 different values and we calculate them accordingly, and we can find out these posterior probability for this combination, right? Okay, I think we can now start coding, and today we will import a very important library which is called NumPy. I believe many of you are pretty much familiar with this library, but whoever just started Python and whoever is not familiar with this NumPy library, I'd like to tell you that this is something very strong. This is something very structured, and it immensely reduces the number of codes to solve a problem. Okay, many complex problems can be solved using different functions provided by this package, right? Okay, so the first thing we have to do now is we have a list of feature and we have list of target. We have to find out unique features and unique targets. That means in our target we have yes, no, no, yes, no, yes, yes, no, and so on and so forth, but we have to find out yes and no. That means we have to write a function that returns the unique target in the unique targets in the target list and the unique features in the features list, right? And we also want to find out the corresponding frequency. That means uh, like as per we counted earlier that we have total 8 yes and definitely 7 no's, so we also want to find out that frequency as well. So NumPy can do it very easily for you. So we are expecting two values. First is, let's say, targets, where I will store all the unique targets that we have in our list, comma, target target frequency, definitely. So when you write two variables separated by a comma, that means here in this part you are trying to write a function which will return two values that will be consecutively stored or holded by this variable and this variable. Okay, so the function is np.unique. Okay, so now if you write target, it will return the unique categories of the target list. Okay, but we are expecting two values from this function, so we have to provide another parameter here, that is return underscore counts is equal to true. Oops, true. Yes, so this part will return the corresponding frequency of a particular target, right? And same we write for frequency, features and features frequency and features. Perfect. Yes, so unique targets and their corresponding frequencies, unique features and their corresponding frequencies. Now we want to write a function in Python. You can write a function by writing def and then a specific name. I'll name it calculate probability. Yes, this is how you start a function. And unlike Java, you don't have to specify any return type for a function, and I think that is pretty much synchronized, and that's pretty much optimal for me as well. Yes, so you don't have to specify any return type. You can return anything or any number of variables as you want. All right, okay, so first, let's not think too much about it, and let's try to iterate through a loop over this list. Okay, before I write this list, I would actually like to show you what these variables are holding. So let's run this code, refresh the terminal, and yes, features, it's holding ABCD unique features, and targets, it's holding no and yes. That's what I said. And in target frequency, the corresponding frequency of corresponding classes, corresponding unique classes or corresponding unique targets, and here frequencies of corresponding features, right? Okay, now what I said, I want to iterate a loop over this targets. Yes, and after that we want to iterate over frequencies as well, sorry, features. Yes, so iterating over this list mean when it's iterating for the first time, it will hold value as no, and then in the second iteration it will hold value as yes. For these features, for this loop, it will first hold value as A, then B, then C, and then D. So if you know the nested loop concept, then you know for target no, we can iterate over A, B, C, and D, and for target yes, we can iterate over A, B, C, and D. That's what exactly we want, because if you check the formula, if you have feature as A and target as yes, right? So you could also have features as B and target as no, features as C, target as yes. So there are so many combinations, and this loop is ensuring us, these two loops, they are ensuring us that they go through all the possible combinations, right? Makes sense? And also we want to take the correspondent, we also want to take corresponding frequencies, right? We have frequencies as well. Okay, so target, I don't know why it's not taking it. Okay, I'll copy and paste this up here. Perfect. And so T will hold value from targets list, and TF will hold values from target frequency, right? So when you want to iterate over multiple lists in a loop, you have to enclose them by zip function, right? Yes. Also, I want to do the same for features here, features and feature frame, yeah, and again I'll enclose them by zip function. Perfect. All right, so for different combinations, we want to find out the number of hits, right? So remember what I said, when you are trying to find out result of this part, we wanted to figure out how many of these combinations are there in our domain, right? Like feature being A and target being yes. So we can do the same very easily here when we will bring feature and target into play. Okay, so we will bring it here in the third loop, whereas if of all and okay, T of all and F of all in zip feature, target and feature, right? Perfect. Now what I'm doing, for each of the combinations we will iterate a loop where we can actually iterate over all the features and all the targets in our domain, and then we will write a condition that will check for any particular combination in any iteration. And when we find a particular combination, we will increase a variable's value, which I will initialize here, hit equal to 0, and perfect. If T underscore all is equal to T and F underscore all is equal to F, right? This means we have found out some particular combination, and for that we want to increase the value of hit by 1. As simple as that. Okay, so when this loop is done, I mean this much loop is done, that means for a particular combination we have found the number of hits. right? Okay, so if for a particular combination we have found number of hits, then we can also find posterior probability for that combination using this formula. So let's solve the first part of the formula here. It's hit. Okay, let me first probability is equal to 0. Now I'll store it here, probability equal to hit divided by, remember what I said, number of hit of that particular combination divided by number of that particular class in the combination, that is TF here. Because let's say if you're trying to find out probability of, let's take this as an example, probability of target being yes given that feature is equal to A, that means you need to find out this combination divided by total number of yes in the target domain or in the target list, right? So that is being holded by this TF for a particular given target class, right? So hit divided by T underscore F. Very simple. All right. So the first part is done, right? And the second part is probability of target being yes. Then again into probability of target being yes, that is number of yes in target list divided by total instances in target list. That we can also find out by calculating or by finding out the length of target, which is done by this len function target, and done. Yes. So let's then close this by parentheses and first bracket here, another first bracket here, divided by probability of feature being A. Very easy, just what I did for target, I'll do it for feature. And for a particular feature's frequency, we have some variable here which is f underscore f divided by len of what? Feature. Perfect. Now I think this should be the outcome. And also, once you have calculated heat for a particular combination, you have to refresh or reinitialize this variable. And on which level we have to do it? We have to do it in this level, because new features are coming from this level. So let's say target being yes and feature being A, we have calculated the total number of hits in our domain, and then it goes back to the target, sorry, to the feature part, and it moves to another feature, that is B. So the next combination is going to be the feature equal to B and target equal to yes. For that we have to reinitialize the hit variable so that it can count for the new combination, new arrived combination, right? Okay, so let's run this. Oops, before I have to call calculate probability. Perfect. And run this. Okay, we have different probabilities. We have total 1 2 3 4 5 6 7 8 yes. For yes we had 4 features, and for no we had 4 features, so total 8. But printing in such a way is not a very optimal solution, so let's write another function, print probabilities. Yeah, yes. So we have to call print probabilities from here. So what we want to pass in, we want to pass the specific target, which is T. We want to pass the specific feature, which is F, and then the probability or posterior probability of that combination. And we print something here, which is this formula equal to the value we got. All right, target being something and feature being something. So P of target being something, and that something is, okay, let me yes, that something is T, then a bar, feature is equal to F, then again brackets close equal to plus str probability. Perfect. So this str function, this is converting this variable to string. So when you are concatenating strings in your print function, it expects to all the variables to be a string, but when you concat a double with a string, it will throw an error. Okay, so that's why, as I had to concat this value with the entire string here, so I had to convert it to string. Right? Okay, now this should be something that looks good. Yes, and these are different features: posterior probability for target being no, and these are for yes. So I received one problem in the group saying that the summation of probability is not 1 but 1.01 or something. So if you add these probabilities, this is not how you add up. The way you have to add up here is, for feature A, target being no, you have 0.5. Now you have to look for something other way around. That means feature equal to A and target equal to yes, which is here. 0.5 and 0.5 is equal to 1. Same goes for this one, same goes for this one, and the other examples as well. So when you add them up, when you add a combination and the opposite combination of the earlier one, you will always get a value as 1. Yeah, but if you add all of them up, and if you add all of them up, it won't give you a value as 1. All right, I think the confusion is clear. And so probability of feature being A, given that the target class is yes, or sorry, probability of features given the target class is yes, we have to multiply all the probabilities here, and we have to multiply all the probabilities here as well. But if you're really looking for like adding probabilities is coming up as 1, you have to add such a way that I have mentioned earlier. All right, so that was pretty much it about this tutorial, and I hope you liked and enjoyed this tutorial. And I'll try to upload second programming assignment as soon as I can. Okay, so have a nice day and enjoy data science.